It is my great pleasure to introduce you to Thorsten Frühauf. Thorsten works at the Sun High Availability Engineering team in Stuttgart, and he's going to talk about high availability with a minimal cluster. So please give him a warm welcome applause so he feels good.
Thank you very much. So I'm pretty happy that this room is filled after a great talk from Simon, and for a topic that I would position myself as a niche topic, but obviously it is important, so I'm grateful that you're all here. So in order to get a feeling for my audience, I would like to see who here in the room has experience with Solaris Cluster. Okay, that's a couple. Who in the room has experience or has even heard of OpenHA Cluster? Okay, even more, that's great. So my talk is about high availability with a minimal cluster. And the agenda is, as you see, I will motivate as of why high availability is a topic that might interest you and what motivated us to think about a minimal cluster. Then I will briefly introduce what OpenHA Cluster 2009-06, which is a product based on the OpenHA Cluster source, is all about. And then I will explain what makes this configuration minimal and what kind of new ideas we brought into the effort to port Solaris Cluster to OpenSolaris. And then, if time allows, I will also have a brief live demo to show a configuration on my laptop, which is clustering two VirtualBox instances running OpenSolaris 2009-06 and OpenHA Cluster 2009-06. And for those of you that are interested how to do this, I've written two white papers now. The first one is to explain exactly the setup that I'm showing you today. The other is about running the same setup but with Solaris 10 and Solaris Cluster 3.2, because that even allows also to run two VirtualBox images and to cluster them. And it is really not meant to be a replacement for the official documentation. It is more like a cookbook to show exactly what I did, and you can do it on your own as well and hopefully result into a working cluster system that I show you. So with that, why care about high availability? I mean, it's pretty obvious for those of you that are using this topic in day-to-day job, but just to remind you, I mean, computer systems provide services. Somehow, if you have a business, you rely on those services. And without a doubt, no matter how bright engineers get with building hardware, at some point they fail. It is not a question if, just when. And I know that some systems have a very nice tradition of staying up very long, and maybe you even forget the location where those systems sit. But at some point they might fail. And in those cases, products and technologies that I'm presenting kick in. They are not there for when everything is running nice and dandy. They are there for the moment when failure occurs. And then it shows if this product is really holding the design and the purpose of what it got designed for and is really acting correctly. So downtime is costly to those that have a business to run, and failures are inevitable. They happen on various layers like software, hardware, and you have even things you cannot influence like natural disasters or terrorism. And there are people and processes. And I always get reminded by people that tell me, oh, well, you are presenting about this nice high availability product. Now, if I deploy it, then I have high availability, right? Right? Wrong. So people and processes is a very big component of this picture that you should not underestimate. So your admins need to be aware and familiar with the technology they are using, especially when failures happen. That's when they get nervous, where their phone is ringing all the time, and people are waiting for a resolution. So this is a very big component, and such a product can only help to implement your goals that you have for high availability. And it's important to be very specific about what you want to achieve and what you want to protect against. So the goal of high availability is obvious. I mean, it is the attempt to automate any response to failures that occur, and to minimize the downtime as the automated reaction allows. So you basically don't want to see your users something like that your important service.com is really not available. Methods to implement HA, and that is being used by any kind of high availability product. The key point here is redundancy. So you have redundant hardware on all layers, like network adapters, storage paths. You have software monitoring, so you have a cluster framework that is software in itself. It serves several purposes. One of them is to monitor the hardware itself, to make membership decisions, to manage applications, start, stop, and probe, and to monitor also networking paths, because even if the processes might run, that's all nothing if the system itself is not reachable by the network. And you fail over if failures occur to the secondary hardware, or if you have multiple node clusters to others of them, when problems are detected. So what we have heard with HA clusters from a perception point of view is they are complex, complicated, difficult to use, requires special hardware, and that point, requires special hardware, is not really true for our product, because it is really designed to be generic. It runs on any system that is capable to run Solaris or OpenSolaris. But here is the important point. If you care about high availability, you want to be sure that the configuration you are deploying has been tested. And that's where it comes down to be much more narrow when we look about support, because testing becomes very difficult and very complex in itself the more components you have to deal with. So we have a very rich set of configurations that we support, both in the Solaris cluster world, and within the OpenSolaris world it is much smaller, as you will see later. But as soon as it comes to support, you want to be sure that those components really work as you expect. And part of our open source efforts was also to publish the source for our testing suites, and we have built-in failure points that we can activate during testing, and we do regression testing and new feature tests on a regular basis, and the whole development process is also designed to have code reviews, multiple code reviewers, etc., etc. So all of this is to ensure that the system runs when failures happen. So nonetheless, this is the perception, and those perceptions are not completely unfounded. So those products, if you have the history, when we started in 1995, building a solution for a parallel database, and moving along with our complicated command line interface that we reworked for 3.2 to be much more friendly and object-oriented, you will see that we have a long way behind us. And we are caring about feedback and customer feedback, and we are trying hard to make our product easy to use, nonetheless, even if it is a complicated topic it deals with. So a typical HA cluster hardware configuration looks like this. You have 2 or more systems. You have redundancy on all layers for networking, and here, at least in the past, you need 4 networking adapters. Why 4? Well, 2 for public net and 2 for the interconnect between the clusters. Because you always need redundancy, and you don't want a single failure to trigger the failover to the other hardware already. So you have dedicated interconnects between the nodes, you have shared storage. Again, you want multi-home disks that are cabled redundantly to both or all systems. And you have a quorum mechanism. And I come to that in a bit to explain why we have a quorum arbitration device, but it is a key component of any cluster basically to ensure that at any given time only one partition of a cluster is active and serves the service reliably, and to prevent that the service is started on multiple machines and really chaotic behavior is being shown. So the typical HA cluster software components you have some kind of heart beating to determine if the other systems are healthy. You have membership, where you determine who is part of the cluster and is able to serve reliable services and who is not. You have a distributed configuration repository, and to keep the configuration of the cluster on all nodes in a way that it is consistent and always correct. You have service management, like the knowledge on how to start, stop, and fail over probe your service. And by a service, I mean typically one or more IP addresses, one or more file systems with associated disk groups, and one or more applications. Then you have the global file system eventually, and you can implement network load balancing as well. So all of those components play a role in an HA cluster software architecture, and that architecture looks like this. And it emphasizes again that this looks really complex, right? So, but those components are all necessary to ensure high availability. For those of you not familiar with the product at all, I want to briefly explain the layers we have. So we have the dual attached storage here. It can be SAN storage, direct attached storage. It could also be network attached storage, then the picture would look a bit differently. But the main point is you have a kind of shared storage. You have also nodes that might not be connected to that shared storage. Therefore, we have something like a global file system, and for this we support UFS and VXFS. And if a file system is mounted globally, then the access to the file system, be it read or write, will be through the interconnect down to the node that is primary and back through the interconnect again. So the interconnect is not just used for heartbeat purposes, but it can also be used for applications that are cluster aware, like Oracle RAC with cache fusion, and for networking traffic that is coming from the global networking service for scalable services. So the type of services we distinguish are failover services and scalable services. A failover service is running at one node at a time, and a scalable service is running on multiple nodes at a time. And with the global networking service, the interface is plumbed and up at one node at a time. It can fail over if required, and it will distribute the load to the other nodes through the interconnect, and those can answer individually. And of course, we have a layer that deals with applications, knows how to start and stop them. I won't go into all of those details. We have also a very rich integration with zones and stuff like that. If you bring in virtualization, it gets even more complex. But I want to talk about a minimal cluster here. So just to emphasize what type of clusters we distinguish. The picture you have seen assumes that the nodes are probably within one room very closely together. You can also build campus clusters where you would separate the nodes in distance up to 400 kilometers, but they are still one cluster. This is useful if your data center provides multiple rooms or even data center locations within one campus, and where you want to separate them to achieve more high availability, to separate also power supply and stuff like that. And then the next step would be to have multiple clusters, at least two, which are again separated by distance. In this case, it can be any distance really. The obvious part that limits the distance is you need some kind of replication going on for your storage, and you see, and the replication can be synchronous and asynchronous. And for synchronous, of course, there are pretty tight limitations that physics and the rules of speed of light bring to the table that we cannot ignore. So latency is a topic here, obviously. But the concept is you have two clusters. They are independent, but you build a partnership. And the partnership includes the replication part and the resource group part, which deals with the application. So a resource group is an object within the cluster that is the entity that fails over. And this partnership allows you to switch a service when you determined disaster at one site to another cluster on a different site. And that decision is a manual decision, but once decided, and it follows the ITIL standards, that you pretty much cannot determine a disaster automatically or by a system. You need coordination with humans, and it is an expensive thing to switch a whole system to a disaster site. So that is on purpose. But once decided, it is a one-button touch in order to automate the whole failover process. By the way, if there are any questions or any problems with my German accent or anything, please tell me. Ask questions if required. So we re-evaluated the HA cluster complexity because we needed to bring Solaris cluster to Open Solaris, and that in itself is not a simple task. I will explain that later. But since we had that opportunity, we thought it should be possible to build a cluster with any systems, with any two systems that can run Open Solaris without requiring shared storage. Now, that includes also some preview features that I will explain, which we currently not support, and we somehow seek feedback if this is something useful to customer deployments. But the goal here is, so Solaris cluster came from a data center perspective. It was always designed for the enterprise. And now we are looking a bit into the good enough approach. And that is where Linux HA is coming. They originally started, without trying to insult them, in the good enough approach and evolved into the data center where they are playing today as well. So we kind of made the other way to look and see if we can provide anything useful in that space. So if your service level agreement, and I stress that, allows you to turn down the high availability requirements, then we can offer a solution as well. But still, we also want to be able to provide what existed today. So not everything needs all of this complexity that I showed to you. And when good enough is sufficient, then why not have a look at new possibilities? So the goals of the project was to provide a lightweight modular cluster that can run on minimized hardware configurations. As I explained, any system that can run on Open Solaris should be able to be clustered. And of course, we want to preserve all the functionality for enterprise deployments as well. And of course, there come various restrictions with Open Solaris itself. I come to those later. So how to get there? We ported OpenHA cluster source to Open Solaris. We had to deal with new features on the Open Solaris platform. We add hardware minimization features, and we leverage Open Solaris features as well, like the image packaging system. There was no way around it anyway. But since we had to rework and rethink our packaging, we realized that it gives us the opportunity to also allow things that customers often ask about, like building minimized systems. And minimized in this context means not installing all packages like the entire distribution or something like that, but a more specific set that is really needed. But what this requires is that you are analyzing your dependencies on the individual packages. So in the System 5 world, what we did as an assumption was that we have a specific meta cluster, and here the word cluster is a bit overloaded, but we have a meta cluster of packages, and we assume they are there. And this is what we test against. And we did not create the individual dependencies for individual packages that we really use or require in order to work. So it was kind of hand-waving then when people say, oh, can I remove this and that package? That has two aspects. One of them is to make sure that the cluster framework itself runs, but then you are installing applications which might bring in new dependencies. So IPS is trying to solve that. We are trying to solve that as well, since we made a very thorough analysis of our specific dependencies and specifying those within the packages. So in order to bring this a bit into context, I've mentioned the Solaris cluster product. So a product is always kind of a binary distribution. It runs on Solaris 9 and Solaris 10 currently. It's fully supported. And at the time when we released 3.2 in December 2006, or I think it was actually January 2007, we thought about a schedule on how to open source the software. So the base is when from what was in 3.2, we have internally a development tree that is reflecting all the current changes. Anything that is being invented newly needs to go there first, and then eventually when it turns out to be stable and something that customers ask about, it is brought back into the product.